Okay. Today we are going to have a discussion on time series prediction by Zahraddeen Karami Lawal, PhD in view. He is a PhD candidate in system engineering at University Brunei Darussalam in Brunei. He is an experienced system analyst, has experience in teaching as a lecturer. He has a history in working higher industry. He has expertise in NLP, big data analytics, data science, machine learning, and Internet of Things. But majorly now he is focused on time series prediction, and all the techniques and all of that, and that's what he is specializing on in his PhD. Last year he gave the discussion to the fellows on time series prediction, and he will be doing the same thing this year. And I'm 100% sure you will learn a lot on time series prediction. I will let him say few words about himself before he commences. Yeah, so I will share my screen very quickly just to have an idea of what we'll be looking at. So this is it. Time series forecasting. It's a machine learning technique where it's used for making prediction on a data that has based on time, change in time, what will happen in the next 1 week, in the next 2 weeks, based on what happened in that kind of any data that has time. Most of the work we've done, almost all the work we did, has nothing to do with time. It's just making predictions based on data without focusing on the time that data is generated or populated. So, but time series prediction has to do with if you time is associated with your data, then you can do a lot of time series prediction. Uh, Normally, we use ARIMA and other models. So he will give an introduction of time series prediction, then how you build ARIMA time series models, and then SVR for time series forecasting. So I'll stop sharing my screen. Uh, Dr. Zahraddeen, you can take over, introduce yourself very briefly, and you can start your talk. Zahraddeen, are you still with us? You should be able to unmute yourself, your co-host. I'm audible, right? Oh. So there is another name. Um, oh. So what I will do is make co-hosts. Yep. Yeah. So I make both accounts co-hosts. Yeah.
Hello, everyone. Thank you very much, Dr. Ibrahim, for a brief introduction. And you have already said it all about me. So as you have mentioned earlier, my name is Zahraddeen Karami Lawal, a PhD candidate at University Brunei Darussalam. So I'm really excited to continue with what I have done last year, which is time series forecasting tutorial. Because me too, I'm still a student, I'm still learning. So I hope the Arewa Data Science fellows will bear with me. I'm still learning, I'm still a student. So now, when we talk about time series forecasting, in our today's world, in our dynamic world, we are surrounded by a lot of data from businesses, from meteorological data such as weather, such as data from weather forecasting, such as sales from finance, stock markets, and many others. So Businesses, researchers, and many others are always trying to find ways to make sense from this information because we have a lot of data. If you take an example of sales of a particular product from a particular company, let's take an example of milk. Let's take an example of fig milk. So over a period of time, WOMCO, which is the producer of fig milk, may try to find the trends or pattern, sales pattern in milk, in the product milk. Let's as I have mentioned earlier, let us take an example of pig milk. So from that, they may make some critical decisions. So businesses and researchers are always trying to find sense or to make sense from this information. So time series data is one of the types of data that we often encounter. It is the data that has a time component, which means that the data consists of time, which may include date and time or date or both at the same time. Initially, that statistical models are used in time series forecasting. Like the previous courses that you have taken, mostly they are focusing on using prediction, using classification. In time series forecasting, our focus is purely on using regression method, because in time series forecasting, we are dealing with continuous data, while in classification, we are dealing with discrete data, because we are dealing with numerical values, that is to say, continuous values, because they are in continuous form. So initially, moving averages, exponential smoothing are used as statistical method for time series forecasting. Later on, ARIMA, which stands for autoregressive integrated moving average, seasonal autoregressive integrated moving average, which we call SARIMA, are also implemented as statistical models. So due to computational developments, there are increase in computational power, but still we need something huge. We need to understand the pattern in our data. So there is a transition from statistical models into machine learning. So different statistical models has been implemented or has been incorporated into machine learning. If you take an example of ARIMA, we can use ARIMA is a statistical models, but it has been improved with the advent of machine learning. So the key machine learning models we are using nowadays are for time series forecasting are random forest, spot vector regression, and advanced ones like LSTM, GRU, among others. So now let me share my screen. Let me share my screen. Can you see my screen now?
Yeah, we can see your screen.
Okay. So time series forecasting is the accurate prediction, is the accurate, or we can say accurate is we are trying to accurately predict the future values of our target, since we are now dealing with, in machine learning we have features, and we are using our features to predict our targets. So we are trying to use our historical values. In time series, we can use univariate time series forecasting or multivariate time series forecasting, which we will later discuss. So what we are trying to do in time series forecasting, we are trying to use the previous values and predict or forecast the future values. Let's take an example of Nigeria, of our today's population, Nigeria, our country today's population. The last time Nigeria had the population census was in 2007, was in 2006, right? That is the last time. So from 2006 from 2006 till to date, if you look at the population of Nigeria, is projected population, because Nigerian Population Commission are using some data, or they are using some information and try to forecast or project Nigeria's population. If you look at our database, there are so many people that are not documented, which means that they are not registered with any governmental organization. More especially, like they doesn't have national ID card, they doesn't have birth certificate, they doesn't have any even driving license, anything that has to do with registration with government. They doesn't have any. But why do we have this population? If you take our population in 2006, which is the last year population census was done, and they are always projecting or forecasting the population of Nigeria using they are using population as target and using some futures. Hope you understand what I'm saying. So let us explore time series. Time series in mathematics is a series of data point indexed in time order. Mostly a time series is a sequence taken at a successful equally spaced points in time. So normally in time series data, you may have a time series data either as hourly data or in minutes, but they must have an equal or regular pattern. Let's say you have the data, if you have, let's say 1,000 data point, it has to be maybe a daily data set, or it will be an hourly data set, or it may be a monthly data set, or it may also be an annual data set. But they must maintain the same pattern in time series forecasting. Like in the previous work that you have done, normally you are using sequential index. Normally you doesn't care whether your data has index or not. By the time you create a data frame, by the time you create a data frame, another column must be created, which will maintain the sequence of your data frame. But in case of time series forecasting, we are trying always to use our time or date, depending on the time series data we are using. Some time series data, you may realize they have date and time. Some they may have year only, some they may have time only, depending on the type of data set you are using. So time series analysis can be used in a distinct form, which we can use to evaluate and understand the pattern in our data set. That is the main essence of using time series forecasting. So time series forecasting uses a model to predict future values based on pattern displayed by previously gathered data. That is historical data. Like in supervised machine learning, what we are doing also in time series forecasting, we are working on supervised learning. In supervised machine learning, we are using historical data, right? So in time series forecasting, we are using historical data, which is previously gathered data, and try to predict the future value. So now let us take a look at these data. If you look at this, you can see that we have a data which consists of CO2, year and month, year and month. We have this data consists of 4 columns, and our only target in this time series data is CO2. So time series has some characteristics. So when looking at time series data, you may notice that there are certain characteristics that you need to take into account and to mitigate to better understand its pattern. This includes trends, seasonality, outliers, long-run cycle, constant variance, abrupt changes, and even stationarity as well. Because in time series, for us to use time series, for us to conduct time series forecasting appropriately, we need our time series forecasting to be a stationary data. But at some point, you may realize that your time series data has some seasonalities. It may have some outliers. So now let us start with trends. Trends are defined as measurable increases and decreases over time. Now, let us take an example of some markets. Let us take an example of some items, like if you take an example of fabric items during festive season, if you take an example of Quarry Market in Kano or any markets that are dealing with textile materials. So during festive season, if you look at their sales, during festive seasons, they may have an increase. But immediately after the festive season, like now, most of the people that are into fabric business or textile materials, after the festive, more especially if you take an example of the northern Nigeria, since most of us, we are from the north. So if you take an example of northern Nigeria, now after the Eid, so they may experience decline in their sales, while the sales they may experience before and during Ramadan will be very high. So if you look at their sales, you may find some trends where there is where there is decrease in sales and where there is an increase in sales. There is what we call seasonality in time series forecasting. Seasonality is defined as periodic fluctuations such as holiday rushes that might affect sales. So if let's say there are some holidays, like I have explained, there is quite difference between trends and seasonality, although they may look somehow the same, but they are not the same. So seasonality in data set due to some seasons, like if you take an example of some products that are seasonal, if you take an example of jackets that most people buy during Harmattan or winter, So that particular product may experience decline, because they are seasonal products. So in seasonal products, you can easily find seasonality because there are some daily products. Then there's an outliers. Outliers are far away from the standard data variance. So for us to understand what is an outliers, not only in time series forecasting, even in classification, you may find outliers. Let us take an example of an example of list of countries in terms of their population. If you look at countries with the largest population, if you take an example of China and India, they have a population of over 1 billion. Like India, their population is bigger than the population of the entire African continent. So now let's take an example of Brunei with a population of less than 500,000, imagine. And there is Maldives, they have a population of less than 200,000. So when you are trying to design a model that may consist of countries around the world and their population, how your model will understand the trends in your data, because you have Brunei with less than 500,000, you have Maldives with less than 200, with 200,000 or around 250,000, you have China and India with over 1 billion. So you have an outliers. You can easily identify outliers in your data set. So later on, you have to, I think you know about all these scaling techniques. You have to employ scaling techniques so that you can scale your data set. Or if you take an example in Nigeria, in Nigerian population, maybe you want to run some experiment based on the amount Nigerian citizens saves in their account. Dangote is there, and many other billionaires and billionaires are there. And there are some people with less than 5,000 or even less than 1,000 in their account, and they are all Nigerians. So you may find some outliers in time series data. There is long run cycle. Independent of seasonality, data may display a long run cycle such as economic downturn that lasts longer than a year. There may be a situation whereby a country may experience economic downturn, or a company in particular, like what is going on now in our country due to the issue of dollar and the issue of subsidy, which badly affects our country's economic. So in this regard, if you look at it, or if you conduct an experiment, or if you have the data set from, you may say from January 2023 to maybe June 2024. So you may find a long run cycle, because there are a lot of issues which affect the cells. So you can easily find this long run cycle. Then there is constant variance. So over a time, data display constant fluctuations such as energy usage per day and night. So this is constant variance. Sometimes we will regard it as stationarity, because the data is stationary, because it has a constant fluctuations. If the data has a constant fluctuations, it has a constant variance. So that is the data which is very good for time series forecasting. Although even the data with some seasonality, there are some methods that we can employ, like seasonal decompose, where we can employ the seasonal decompose to decompose the seasonality in our data set, so that our model can understand the pattern in our data set accurately. Then there is abrupt changes. The data may display abrupt change that need further analysis. If you take an example of COVID-19, businesses around the world are shut down for many months in some countries, or fewer months or days in many countries around the world. So if you look at it, there was an abrupt, it is something that goes up abruptly, so which affect the economy. That if you look at it, there are so many research that has been conducted about how COVID-19 affect businesses and other daily life activities. So I skip this. So in this lesson, we will be using the univariate time series forecasting. So we will build ARIMA model using univariate time series forecasting. In univariate time series forecasting, we are focusing on one variable that change its value over a period of time. Like in the previous machine learning models you have built, you must have futures and targets. But for us in time series forecasting, you may have a single variable that can serve as future and target. What we are doing, this one we call it univariate time series forecasting. Like if you take an example of this, we have CO2, which is CO2 emission. If you look at it, it's CO2 emission. But the remaining three features in our data set year, month, year, and month. If you look at it, the only variable that is useful for us in this regard is CO2. So what we should do is we will try to use the past values of CO2 and predict its future values. We can divide our data set into training and test. Do you understand? With only one variable in time series forecasting, you can build your model. Unlike in the previous in classification, you must have independent variables, which are the features, and dependent variable, which is the target. But in time series forecasting, we can deal with only one variable. We can build our model. So let me share the screen again. So let us start with ARIMA model, and if we have enough time, then we can move to SBR. And maybe tomorrow we will discuss linear regression, and maybe we will try to run some cross-validation, hyperparameter tuning and cross-validation of ARIMA and SBL models tomorrow, if time permits. But today I will try to start with ARIMA model. So let me share the screen again. Stop sharing the screen. So we'll now start. Let's start. So in this cell, we imported the necessary libraries, which includes pandas, NumPy, matplotlib, and ARIMA from start models. So I think this is the only library maybe you have never worked with before. So you can import you can using pip install. You can install this library start models. So now the next after we imported our necessary libraries, the next thing is to create data frame from our CO2 data set. So looking at this, you can see that we have index. We have index, which is normally generated whenever you create a data frame in machine learning using pandas. The index is normally generated. Like in the previous machine learning work that you are doing, normally you are using this index. But for us in time series forecasting in this regard, our focus is our model to understand the pattern in our data based on time. That is why we call it time series forecasting. So now what we should do is to set year and month to be our index instead of this index sequential index from 0 up to 160, because our data set consists of 161 rows. That is, which means 161 data points and 4 columns. And in these 4 columns, as I have mentioned earlier, the only column that is our main focus is CO2 emission. So we will now set year and month as our index. Now take a look at our data frame now. Now our data frame has three indices. It has three indices, I mean. It has three indices, which consists of year and month, year and month. So the next thing is to try to use this. We are now extracting this COT column from our data set. So now the next thing is to divide our data set into train and test sets. Although into train and test set. So is this, I have taken 80%. If we like, we can take, let's say 70%. If we like, we can take 70% for the train side. And if you look, I did it manually. If you look at it, I did it manually. And the next thing, after we split our data into training and test sites, which you are familiar with, the next thing is to use window size or sliding window. In time series forecasting, we have what we call sliding window, look back. Sometimes it's called look back. And we have what you call forecast horizon. So as the initial stage, our focus is to use window size, which means that in this regard, sliding window is a technique in which you can use data processing and analysis, where a fixed size window moves over a sequence of data points. The window acts as a frame that captures subset of data at a given time, and it slides or moves from one step at a time, sequentially. But if you like, if let's say we are using focused horizon, that is what we call a horizon. In case of horizon, it is a little bit different from window size, I mean sliding window or look back, because in window size, for instance, now we are taking window size of 2. In the case of window size or look back, our model will now look at the previous 2 values and predict the next one. But if it is focused horizon, if let's say we set our focus horizon as 2, it will now look at the previous values, the last 2 previous values, and predict the next 2 values. That is the future values. This means that in sliding window, whether we take window size of 10, at the end of the day, we are predicting 1 value. But in case of focus horizon, if we take a window size of, horizon, if we take a size of 10, let's say 10, so we are using the last 10 or the previous or the past values, past 10 values to predict or to forecast the future 10 values. That is the next 10 values. So this is the main difference between focused horizon and window size, sliding window or look back. Also, whether it is window size can be used, the term window size can be used either in focused horizon or sliding window. In some cases, you realize that they are using look back. So now, the next thing is our window size. If we like, we can change it, let's say, to 5 or even 10, depending as you wish. So now, I'm now trying to initialize a list of 2 variables, which are predictions and actual values. So in time series forecasting, after we did our forecasting, what we are doing is to try to compare the predictions, that is the predicted values, and the actual values. We are trying to compare the predicted values and the actual values to see where they are very close and where they differ, because it is a prediction. Sometimes you realize that predicted values is lower than the actual values, or at some instances, the predicted values is higher than the actual values, or they may reach equilibrium where both predicted value and the actual value have the same values, which means that they are at equilibrium position. So now let us apply the sliding window approach. So if you look at this code, for I in range length test data, you know how to find using this, you know, in Python, you know, we can use to find the length of test data minus window size plus 1, because initially it was 2. That is why I use window size plus 1. Let me change it so that let us use 2 as we did earlier. Later on we can change it. So window size plus 1, because we are using 2. So window size minus window size plus 1. If let's say it is 5, it will be minus window size plus 4, because we are using a sliding window of 5. So now train window is equals to train data. You know how to slice, you know how to slice your data. So now now we are slicing our data I plus window size. Then model, we are now creating model ARIMA, because we have already imported our model ARIMA model. Train window, which we have already created and assigned train data to it. Then we have an order of 101. So we create, with the creation of ARIMA model, we have an order of 101 and fit it to the training window. We obtain one-step forecast using this model. Then we stored our predicted values. We stored our predicted value. Model fit is equals to, we first model fit, model.fit, then our forecast is equals to model.fit, forecast step is equals to 1. Then predicted value is equals to forecast.ilog at index 0. Although we are using time series forecasting, but we have to still consider the indices in our data set. So at this point, we are trying to append our predictions and the actual values, because after we finish our forecasting in time series forecasting, in most cases, what we are doing, we have to try to compare the predicted and actual values. So now, once it is done, we have to obtain the training data by appending the next actual values. So we have almost now 2:46 in Nigerian local time. So now, after we finish with our training, of ARIMA model, we update the training data by appending the next actual values. So the next thing is to evaluate our model. Like in case of classification, in the previous classes you have taken of machine learning, mostly the focus is to evaluate our model based on its accuracy, precision, recall, F1 score, coin kappa, and many other evaluation metrics. But in time series forecasting, since we are dealing with regression, it is a regression problem. We are dealing with continuous values in time series forecasting. We are dealing with continuous values, so it is a regression problem. In case of the previous classes that you have taken, is classification. Mostly you are trying to find the accuracy of your model by trying to find the accuracy precision recall, and the remaining other evaluation metrics that we are using. And in that case, your target may either be in form of binary classification, whether it is 0, 1, yes or no, or it may be a multi-class classification. But in case of time series forecasting, mostly our focus is to evaluate our model using mean squared error, mean absolute error, root mean squared error, mean absolute percentage error. These are the evaluation metrics mostly we are using in machine learning for time series forecasting problems. We can also evaluate our model using R-score, that is R squared. You understand, like we can also evaluate our model using symmetric mean absolute percentage error. There are many evaluations, just like in case of classification. In regression, which time series also falls under, we have a lot of evaluation metrics that we can use to evaluate our models. So in this regard, we are evaluating our models using mean squared error, mean absolute error, root mean squared error, and R-score. So if you look at the values we have got from this, the mean squared error has 203, which is huge. So also mean absolute error is 13.6, which is approximately 14. Then we have root mean squared error, which is 14.27, and even the R-score, which is supposed to be from 0 to, which is supposed to be from 0 to 1. So from this, you can understand that there is a problem with our model. Now, what next? If you look at our model, it means that our model is overfitting. It's not learning the pattern in our data. So what shall we do? What we should do is to try to incorporate hyperparameter tuning and cross-validation techniques so that we can try to find the best way for our model. Because what we are doing, we will try to find the best way for our model. We'll try to find the best hyperparameters for our model so that it can predict our futures values accurately or appropriately, which means that our focus is to try to find the future values that are either equal or very close to our actual values, because we are doing forecasting, so we cannot be 100% certain about our prediction or forecast values, right? So the next thing, the detailed explanation of this evaluation metrics is included, and I will try, inshallah, to share. I don't think I have uploaded this repository on my GitHub account, but I will try by tomorrow, inshallah. I will share my GitHub link account so that you can be able to download these files. I mean the entire repository. You can be able to clone the entire repository. So now, right from this evaluation, the values we got from this evaluation matrix, we can understand that our actual and predicted values, the gap must be huge because they are not close. More especially if you look at the R-score, that is R squared, which is ranges from 0 to 1. Now let us plot our actual versus predicted values. The errors. 96. This data point. getting some error. Data frame just has no attribute frame. I'm trying to, because we are what I'm trying to convert the series to a data frame. This is what I am trying. So I don't know whether the latest version of transit I'm using. Let me try to figure it out. Sorry, I'm getting some errors. I'm trying to reset because I'm getting some errors from this frame. I don't know. Because what I'm trying to convert the series to a data frame. But I have done it already on it. Let's see. Oh, frame that is giving me this convert data set frame. Data set frame. That's data I'm getting is so I'm getting, please, sorry, I'm getting some errors because I'm getting some errors from this data. Let me try to verify because I don't know why it's giving me this. I don't know because even yesterday I tried to run it. I tried to run it yesterday. I don't know what happened. Now it is giving me an error, has no object. Data frame has no object. This error. That is data is, let me try to create. Because I've already created We have already created data frame for this. So I don't know why it is now giving me this error. It has no attribute frame, and I have run it yesterday. So now we are running out of time. I'm very much sorry because I have already run this yesterday, but I'm getting this error. I don't know. So inshallah tomorrow I will try to, because we are running out of time, I will try to rectify this error. Then tomorrow inshallah we will discuss time series forecasting using SBR that is support vector regression, linear regression, and if time permit, we will try to see how we can improve this model by incorporating hyperparameter tuning optimization techniques to find the best hyperparameters for our ARIMA model so that it can perform our model can perform very well by trying to understand the trends and pattern in our data so that it can predict the predicted values that are more closer or equal to the actual values. So I'm getting errors. To be honest, I don't know how this happened because yesterday I run this program. So Dr. Ibrahim, let me go through some questions. Let me go through some questions. Oh, okay, let me try to convert. So the first question says, what does statistical model do and what does it contain? I mean, what does it help to achieve in data and its content? For instance, we understand that the language model helps in tasks like summarization, question, and answer. Also, we know that language model contains tokenization string in which it was trained with. So now, in time series forecasting, we are not only using statistical models, we are also using machine learning models like random forest, and the most commonly used machine learning models are linear regression, autoregression, and there are some other advanced machine learning models. Ensemble models sometimes are also used in time series forecasting while trying to use weak learners. By incorporating the accuracy of weak learners, you can use the majority voting trying to find the best model, like bargain boosting. All these techniques are also used in time series forecasting. And apart from that, at advanced level, LSTM, long short-term memory, GRU, gated recurrent unit, are also used. So also artificial neural network in some cases is also used, but the most commonly used advanced time series forecasting techniques or algorithms are LSTM, GRU, and nowadays transformers are also used in time series forecasting. So like you have mentioned, like language model helps in tasks like summarization, question and answer. So in time series forecasting, let us take an example of weather forecasting. Weather forecasting, now based on the weather forecasting report of today, you may decide what to do tomorrow. Because tomorrow, let's say you receive a weather forecasting of the next 3 days. Although it may be accurate, or in some cases it may not be. So apart from weather forecasting, like in businesses, take an example of a big company. So sometimes if they are experiencing declines in their sales, they may need to try to understand what happened. Let us take our sales data set from so historical data set of our sales from so time to so time, and see what happened within those periods, and now what is happening, because they are experiencing decline. So they may try to look at so many things to make a critical decision. If you take an example of the population of Nigeria, I have been saying now, based on the projections that Nigerian Population Commission is given, everyone agrees that the population of Nigeria is projected at so. And for the last 16 years, you can say for the last 16 or 18 years, there is no any population census. So we are just using forecasting. We are just projection. It's just a projection. So once again, please increase the window size. And the other one is trying. I have tried this false. I don't know what happened actually, because yesterday I've already run this. I have already run this yesterday to make sure that everything is okay. So unfortunately, I experienced this. Let me try, because I am running out of time. I know it is only 1 hour. So inshallah, by tomorrow, I will try to rectify this issue so that by tomorrow we'll start with this and move to the next topic, because tomorrow there is no introductory lecture, so it will be purely practical. I'm very much sorry. I've already mentioned earlier, I'm a student, I'm still learning. So thank you very much for having me. If you have any other question, so you can ask. Dr. Ibrahim.
Assalamu alaikum. Dr. Brian is not available on the call, but we're really. Dr. Brian is not available on the call.
No, he's not available. He has already. Okay, no problem.
Yeah, so he have already made me a host.
Okay, no problem. Okay.
Yeah, we're really grateful for, and looking forward to see you tomorrow.
Okay. Okay, so thank you for having me. Please bear with me. I'm also a student, like I'm still learning. Hello?